The topic which I am going to cover for today is application of context-free grammar in natural language processing. First, we'll go through grammar, then context-free grammar, then natural language processing, and then we'll combine those and see what the applications are. Okay, what is grammar? So, grammar is defined as rules for forming well-structured sentences. So, basically, grammar is just a set of rules which we follow to get meaningful sentences. While describing the structure of well-formed programs, grammar plays a very essential and important role. In simple words, grammar denotes syntactical rules that are used for conversation in natural languages. Since it denotes syntactical rules, it will make sense that it's for understandable sentences. The theory of formal languages is not only applicable here but is also applicable in the fields of computer science, mainly in programming languages and data structures. Since we use formal languages in theory of computation, which comes under computer science, and we use data structures for formal languages too. So yes. For examples, we'll take in the C programming language where the grammar states how functions are made with the help of statements and stuff. So mathematically, a grammar can be written as a tuple NTSP. N of V will mainly use V for set of non-terminal symbols or variables, and sigma or T will also use sigma for the set of terminal symbols. S as start symbol, where S belongs to N, which is set of non-terminal symbols. T is production rules for terminals as well as non-terminals. It has the formula of A to alpha to beta, where alpha and beta are strings on V or N, set of non-terminal symbols or variables, union terminal symbols, and at least one symbol belongs to Bn. Now we'll go through context-free grammar (CFG), which is a notation used for describing languages, and it is a superset of regular grammar. So a context-free grammar is just a set of rules that express the ways that tokens in the language can be grouped, ordered, and classified. So now we'll go through the finite set of grammar rules having the following four components: set of non-terminals V, as we discussed before, and sigma set of terminals, set of productions as P, and the start symbol as S. We'll just quickly go through an example for the CFG, and we'll just take a simple parts of speech class of the words from an example vocabulary. This is simple, right? A noun, 5 nouns, 3 verbs, pronouns, adjectives, proper nouns, and stuff. We'll just take a set of vocabulary and classify them as lexicons, and this one we'll just go through them. Now the symbols that correspond to words in the language are called terminal symbols. This one, these are called terminal. The, and, this, these, that, cat, dog, chicken, fish, everything on the right side is known as terminal, and the set of rules that introduce the terminal symbols is referred to as lexicons. These are known as lexicons. We might have studied them as the start states or stuff, but these are known as lexicons. Now we could use this example to generate a sample text by passing or generating. We'll see an example, but many softwares use this for grammar. Passing is used by many softwares for grammar. We know that we can add as many rules to a CFG as we want, right? For instance, the production on the right defines a noun phrase to be composed of a determiner followed by a nominal, which we define to be one or more nouns. Any symbol, since we know that any symbol that is not a terminal is referred to as a non-terminal. So in here we'll take a determiner and nominal. Nominal can be defined as a nominal noun, and nominal can be further defined to a noun. And verbs are separate, so we haven't taken any verbs in this one, so we'll just add it on laterwards. So we'll take the for the terminal, and fat for the noun, and cat for the second while fat can be used as an adjective here too, we'll use it as noun. Then yeah, so now this sentence makes sense, right? The fat cat ate chicken. Yeah, this is what an example CFG should be like. Now we'll look over the past tree. The bracket notation we used earlier is just a shorthand notation of the past tree. So we can just, this one is noun phrase, so determiner and nominal. We'll take the from the determinal and nominal noun nominal, so fat, and then nominal can be further derived to noun, so this one. Verb and ate, verb is ate and noun chicken, so we'll just take it later for this one since we don't derive it from the past necessarily. When specified properly, the CFG defines a formal language, and thus all sentences that can be derived by the grammar rules specified are part of the formal language. For example, in this, we'll take S as NP and VP, and SP is pronoun, proper noun, det nominal, and nominal is nominal noun, so on and so on. So now we'll go through an example for this one. Now we'll take the example. We'll take S as NPVP. So since S is start state, NPVP, and NP we can derive as pronouns. Pronoun can be derived as I. I'll just take an example for now. And verb, from VP we can take verb and NP. So we'll just substitute over here and prefer. And for NP we can further derive it as this one, det and nominal, det nominal, determiner and nominal. So we'll take a determiner as A, and for nominal we can just take another nominal noun, right? So we'll take another nominal noun, and further we'll take nominal as noun the next time. So I prefer a morning flight. Now as we did to generate this, we can just reverse it and break it. That's what this sentence states. We could apply the rules of CFG to break any sentence to its constitutional grammatical components. So by this, most of the softwares use this to check for grammar, and if the parsing is incorrect or it doesn't make sense, then it raises a negative, which is what we see in Word and stuff as the red lines or green lines under the word. Now this is very useful because CFGs can provide powerful features for your algorithms, especially in the absence of data. Since in the deep learning stuff and AIML stuff, we require lots of data to train the algorithms. But in CFGs, we can just figure out a logic or like uh, like a set of strings and stuff which will start by this, so that then we can know which CFG algorithm we have to put to get the desired output. This is very useful since deep learning requires a lot of data. Same for AML, but in CFGs we can minimize the data requirement and by use of past trees and stuff. Since yeah, grammar checking, that's what I was trying to say. The grammar checking in word processing systems, for example, a sentence that cannot be passed may have grammatical errors, or at least be hard to read. Yeah, so this can be done using a CFG because of the less amount of data that we collect for this one. Now we'll go through another topic. What is natural language processing? So NLP refers to the branch of computer science, usually a branch of AI concerned with giving computers the ability to understand text and spoken words, much the same way human beings can. So yes, NLP is used to process the spoken language like English, Tamil or Hindi or whatever language you prefer, so that machines can understand it, or like computers, modern day computers can understand it. But in this context, we will use CFGs for NLP since CFGs require marginal data, and since we don't have that much data available unless we have like companies database and all, which will be very preferable if we have like deep learning or neural networks. NLP is used in modern day too, like how the chats are using and the text messengers are using NLP to process the content and suggest like relevant to your text, that's NLP in process. So as you have searched, for many search engines use NLP since most of the indexing is done in human language. Now another important topic, after which we'll go to applications of this. Why is NLP important? Since businesses use massive quantities of unstructured text-heavy data, I need a way to efficiently process it. A lot of the info created online and stored in databases is natural human language, and until recently, businesses could not effectively analyze this data. This is where NLP processing is very useful. So, going through this manually is close to impossible since it's like tons of data and we don't have that much manpower. While we can use CFGs to like figure out how the businesses want to reach the customers and stuff, CFGs will be proved to be very useful. Now we'll go through this in the applications and uses. Applications and uses of CFG in NLP obviously. So if I want to like extract all customer suggestion commands from search history, then they are mostly similar in structure. That is, they mostly begin with a verb phrase and have no subject obviously, like show the latest movies, give me yesterday's news, and list all flights. These are verb phrase: show, give, list. These are all verb phrases. So I can just simplify it through just a simple CFG to like get the most searched commands so that we can rank it above the other, or like store it in a cache so that it gets easily recoverable, so that not a lot of optimization or this one is required for every search. Or if I want to like extract all yes or no questions from historical call transcripts, since such questions tend to start with an auxiliary verb yes followed by a subject noun phrase followed by a verb noun phrase. So auxiliary verb, did you try resetting the computer? Subject noun phrase, try resetting the computer. Verb noun phrase, computer. So in this one it's reversed, but everything else, subject noun computer, feel warm to touch, can you tell me how much RAM you have? So these are all very not very simple, but they can be done using a CFG instead of like dumping huge amounts of data into deep learning or an AML algorithm and stuff, since this is very efficient and it's very accurate compared to deep learning in its early stages. So similarly we'll look over another application too. Now the another application I was talking about is how to like organizing and extracting all open WH questions, like who, what, how also lands in the WH questions. So like what programming languages are best for new coders, which Python library should I become familiar with, what is the point of GitHub, and what is the point of life and all that. So since this is starts with WH, we can just design a simple CFG to classify or like extract all the WH questions so that we can just organize the data or search how much people are searching for, like what is the point of life, to get a feel of like the happiness level and stuff. This will be proved to be very useful since yeah, similarly AML will take a lot of time and data as I keep talking about, but this one doesn't require much data or any data at all, since we just have to like hard code this one so we can get that. Now that's all I want to say. Thank you. Now thank you. I referred Master NLP by Chirag Goyal at Analytics Vidya and a YouTube channel at Professor Gasimi Lectures. Thank you.